Welcome to the channel Professor Davinci. Next topic we are going to see about the data distribution. When analyzing the data, it's important to understand the distribution of a data. For example, you are analyzing say data, the coin flip. Okay, if you are flipping the coin, what is the possible outcome? You may get the head or tail. Okay, so the possible outcome is only two. Now if you are going to analyze the speed of a car, so speed of a car lies between, say, assume that 0 to 200 kilometer. So there are many instances are there. Okay, but here only two instances, this or this. Okay, so when analyzing data, it's important to understand the distribution of a data. The distribution refers to how the data is scattered across a certain value or range. By examining the distribution, we can gain insights into the characteristics and patterns of the data, which can be useful in making informed decision or decision making or prediction or whatever analysis. There are several types of data distributions out there. Okay, each plays a unique role in analysis. Understanding this distribution is a fundamental aspect of data analysis and can help you to make more accurate and meaningful interpretation of data. Okay, so because why the distribution is so important? If you are going to work with any analysis, so for example, I am going to work with a coin flip. I am going to analyze the flip. What is the possible outcome? So I must have the knowledge that what would be the range of data I get. Either head, 0 for head, say 1 for tail. If my data analysis algorithm produces a data, say 2, in this case, if I don't have the knowledge of a data distribution, I would wrongly take these two as one of my output. So in this case, this creates a error in your analysis, or this may degrade your performance of your model. Or model means what? Machine learning analysis. Okay, or machine learning model, or a data, a mathematical model. Okay, so this is called a error or a noise. So this noise will hinder my performance of my machine learning algorithm. And if I am doing analysis of the speed of a vehicle, say the speed of a vehicle always assume that ranges from 0 to 200. During the analysis, I give some inputs of a different variants, and I'm getting the output, say 180. So 180, yes, this comes inside the range. Sometimes it may go away, say 210. In this case, I should not engage this kind of data. In other words, the prediction of age based on the a walking pattern or a face recognition from the face, I can um, predict the age. So always the age lies between, say, from 0 to maximum, I can say 110 years. Okay, so my analysis or my algorithm must produce output within this range, otherwise my analysis may go wrong. So this is to make analysis, we need to know the fundamental distribution of the data. Understanding the data distribution helps to gain valuable insights into different aspects of business, such as customer trends, marketing performance, and financial forecasting. So why we should care for data distribution? To gain advantage of data analysis and decision making is a critical to comprehend the various method of data distributions, okay, and also how the data is spread across Lean, Six Sigma, many things are there. Okay, we will learn one by one. Six Sigma and the cross statistics, many things we will learn one by one. First of all, you know about the distribution. Data distribution, the main types of data distribution are two types. One is discrete data. This is the first type, and the second type, continuous data. Continuous data. Now, what is continuous data? For example, I can say continuous data is a data that can take any value within given range. For example, this one, the kilometer example, the speed of a car. That means the continuous data is the data that can take any value within a given range from 0 to 200. I can say there are thousands of values are available. This range can be either finite or infinite. So this is the finite because due to this speed of the car is a finite. Suppose if I want to count the endless, for example, number of stars in the galaxy, so it goes millions and millions, above million, so it may consider as a infinite. For example, depth of a ocean, weight of a person, or length of a road, or length of a anything. Okay, so these are the continuous data, right? So discrete data is a data that takes only a specified value. For example, here, what is the output of a coin? Either head or a tail. What is the output of a dice? 6 faces, 1 2 3 4 5 6. So discrete data is the data that takes only specified value. For example, if you give a test, you can either pass or fail. So the data is discrete. Discrete means what? Either this or that finish. Prescribed, precise value. So the data is discrete in this case as it has only two specified outcome. This is the discrete data and this one is the continuous data. These are the two broad category of a data distribution, but here we have many subcategory. For example, if I use another color. Why I reduce my size? Okay, right. Now, good. Discrete data. Several types of discrete little I increase the size. Several types of discrete data we have. One is binomial distribution or discrete distribution, not discrete data. Discrete distribution. Discrete distribution. Binomial distribution. Second one, Poisson distribution. Third one, hypergeometric distribution. Fourth one, geometric distribution. Okay, so these are the types of distribution we have in a discrete distribution. Distribution have binomial distribution, Poisson distribution, hypergeometric distribution, and a geometric distribution. And similarly, in continuous data, actually, sorry, it's not data, it's a distribution. Okay, in continuous distribution, in continuous distribution, we have several categories, several types. First one is normal distribution, normal say distribution. The second one, log normal distribution. Third one, F distribution. Fourth one, chi-square. Chi-square distribution, very important distribution. And exponential distribution. Exponential distribution. T-student distribution. Weibull distribution. And finally, non-normal distribution. So these are the types of distributions we have. Okay, now I'm just giving a small summary of these four. Binomial distribution. Binomial distribution describes the probability of a certain number of success, say pass or fail. So example is this one. So coin flip. So here only we get 2. By means what? 2. We know that by means it is 2. So the output always only 2 outputs. 2 output, not 2 possible outputs. Okay. This type of distribution is used whether there are only 2 possible outputs for each trial, such as success or failure, head or tail, yes or no, etc., with the equal probability of each product or each outcome. The binomial distribution can be used to calculate the likelihood of achieving a specific result from the multiple independent trials that have only 2 possible effects. So this is meaning I can have several marks of several subject number 1, subject number 2, subject number 3, subject number 4, subject number 5. I have some marks of each subject, and finally I calculate the grade. Finally I calculate either the student have passed or failed. So the output is 2 things. So first student passed, second student passed, third student failed. Okay, so based on the several input feature, I can say the output falls in only 2 category, pass or fail. So this type of outcome is called a binomial distribution. And second, let's go for second is Poisson distribution. Poisson distribution, let us consider a scenario. We can use the Poisson distribution to model the number of calls the call center receives in an hour. So in short, I can say Poisson distribution describes the probability that the event occur within a fixed time. So for binomial distribution, we don't consider the time, but in Poisson distribution we consider time. But some event may occur from this time, say from 8 p.m. from 8 a.m. to 8 p.m. Do this customer may come or not? Okay, but we do know that customer may come in which time range, because we don't have any fixed time. Okay, so in short I can say that a Poisson distribution describes the probability that an event will occur within a fixed time period when its rate is known but its exact timing cannot be predicted accurate enough to measure it directly. This type of distribution is used for modeling random occurrence such as customer arrival at the store, phone call received by a call center, etc. where the average rate of occurrence is known but the exact time of the occurrence of the event cannot be judged directly. So this is called this type of distribution is called Poisson distribution. And the third one, we go for the third one is hypergeometric. The hypergeometric distribution describes the probability of a certain number of certain number of success or failure in a given number of draws. Okay, or suppose for example we can say the population when a draw or made without replacement or with the replacement. This type of a data distribution is used in a situation where an urn contains of different items such as, for example, see here, very simply I can explain. I have a box, okay. In the box I have a red balls and some black balls and some blue balls and some blue color ball. I need to pick randomly. I need to pick randomly a ball, but what is the probability of a certain color of ball is drawn? Okay, so what is probability of a blue color? What is the probability of getting a red color ball? What is the probability of getting a black color ball? Okay, so in this case we have only prescribed precised either blue or black or red, but we don't know when I can take the two blue balls continuously or when I can take the one blue ball and one black ball continuously. So this kind of distribution is called the hypergeometric. And finally we have geometric. In geometric distribution describes the probability of a success occurring on any given trial in a series of independent trials when the probability of success for each trial is known. This type of distribution can be used to model a number of failures that occurs before the success, such as manufacturing process. For example, this is the independent. Okay, now here how many failure I can face for one success, or how many success I may face before a failure. So this kind of outcome or analyzing the outcome in this pattern or certain pattern is called geometric distribution. Okay, clear? So these are the four fundamental types of discrete distribution types. Repeating once again, distribution of a data is very important for analysis because we should know what would be the outcome. If we don't know the outcome, then the analysis algorithm, the machine learning algorithm may give you a wrong answer. If you don't have the knowledge of a data distribution, you may wrongly pick that output. That will cause the hindrance or it may degrade your performance of your algorithm. So for that we need to understand what kind of data I'm using. So the kind of data that's called distribution. What is the range of output I can get? That is called a distribution of data. In these two terms we have discrete distribution and continuous distribution. In discrete there are 4 types out there, in continuous there are 6 types out there. Okay, already we have discussed. Okay, right, understand. See you guys, have a great day.